Good morning, everyone. Do you have any questions? Okay, so today we are going to start chapter 9. And in previous chapter 8, we talked about observational study, kind of. So in previous chapter, we were talking about sampling. What kind of samples are good and what kind of samples are not good. So today we are going to talk about two different study. One of them is observational study. Mostly previous chapter was observational study. And then another one is experimental study. And then in this chapter we are going to focus on experimental study. Okay, so what is observational study? What is experimental study? These are kind of two different methods to collect the data, kind of. So, whenever I observe some individuals and collect the data, collect the information, and try to just observe, not change anything. Like if I give you a questionnaire and you answer some question, you're just giving me some information, correct? And I'm not changing anything. I'm not, changing any condition for you, any situation for you. So you're just giving me some information and I observe, I enter the data and I start my data analysis. This will be observational study in compared to a situation that I'm changing a situation for you. For example, I tell you, okay, this time study 2 hours for this test. I want to see how this 2 hours of study affects on your test score, and then another time I will ask you, now study 5 hours. I want to see how increasing the study hours will increase your exam score or decrease your exam score, effect on your exams. So I'm changing something, yes? So I'm doing experiment. I'm imposing some treatment, different hours of the study, right? So this kind of a study that a researcher or a statistician is trying to impose a treatment or change a situation or affect on the individual to see how the response variable will change is experimental study. So the difference between experimental study and observational study is that treatment, imposing a treatment. So for example, if I have these plants in a garden and I'm just observing these plants and writing down some information like how many leaves they have, what is the color of each flower or everything else. So that would be just observing these plants and writing down information without changing anything, right? So can you change this to experimental study? Tell me how I can impose treatment to this plant and make it like an experimental study. Can you think about any different kind of treatment that we can impose on this plant and write down the information after imposing treatment?
Amount of water to the plant.
So yeah, water. So I will give them a specific amount of water weekly or monthly or daily, and then the other time I will change the situation. I say, okay, I will change the type of water or the time that I'm watering this plant will change, and then I have two different situations, right? The first time I have some information, other time I will have different information because I changed the situation. I impose some treatment. So that would be fertilizer, right? So one type of fertilizer at first, and then the other time I am experimenting on different kind of fertilizer. So even an observational study can become a kind of experimental study, right? So experimental studies happens whenever we impose treatment on individuals and try to change the situation for them and write down the information to see how this change will affect on the response variable. So let's see read some example to see how we can recognize one study is experimental, one study is observation. It says, in general, when trying to change your behavior, in the effort required is perceived as high. This will be an impediment to change, whether it's modifying your diet or studying habit. Researchers divide 40 students into two groups of 20. The first group reads the instruction for an exercise program printed in an easy-to-read font, this kind of font. And then the second group read identical instructions in a difficult-to-read font, this kind of font. Each subject estimates how many minutes the program will take and also uses a 7-point rating scale to report whether they are likely to include the exercise program as a part of their daily routine or not. So the researchers hypothesized that this reading about the exercise program is a more difficult to read font would estimate that the program would take longer and they would be less likely to make exercise program part of their regular routine. So, if I ask you what kind of a study is that, observational or experimental?
Experimental.
Experimental. Why?
Because it uses different types of fonts.
Different types of font, right? So we have different kind of treatment. We are imposing some change. We are imposing some treatment. So you will say this is experimental study. Why? Because we are imposing some treatment. Correct? So to explain that, you can say because there are two treatments and we are imposing a change or imposing treatment. Okay. The next study says researchers studied a group of 10,892 middle-aged adults over a period of 9 years. They found that smokers who could had a higher risk of diabetes within 3 years of quitting than either non-smokers or continuing smokers. Does this show that stopping smoking causes the short-term risk for type 2 diabetes to increase and the rest? Okay, is this experimental study or observational study? Observational study, correct? Because we didn't change anything, we didn't impose anything. We just observed them. Some of them were smokers, some of them were non-smoker, and we record all the information we have, and that's it. We are not changing anything, correct? So now you know what's the difference between experimental and observational study. Okay, so now I remember once I was kind of talking about Lec15 variable. So we already talked about response variable, explanatory variable, correct? So we said explanatory variables, maybe one of them, two of them, many of them, will have effect on response variable, correct? Cause a change in response variable, right? So we know this too in this study. So now let's say the study of, your study time, the effect of your study time on GPA. I have this information about your GPA, your study time, let's say test score. Study time and test score. And then I have this information, and then I understand that something is wrong and it's not like the way I expected. I expect that increasing the time of the study will have a really positive impact on your test score, correct? And all of a sudden I see something is wrong, and it didn't have, for some of the students, didn't have a positive impact on their exam score. So what happens? I will go back to the situation, check everything to see what was wrong. Probably there were some variables at that time when you were taking your exam that had effect on your exam score. What was that? For example, I recognized, wow, temperature in this room was so high that day, and a student couldn't, feel comfortable when they were taking their exam. Or the other class had too much noise, and because of that too much noise, my students were distracted and they couldn't perform well in their exam. So study time was not the only variable that could change the exam score, right? There were some other variables could have effect on the exam score, and I forgot to mention those, and I didn't consider them in a study. I considered them, I reviewed them after I understood maybe there was something wrong. That's why I didn't get a good result. So these variables, which are kind of hidden, you cannot find them at first, but they will have an impact or effect on your result. They are lurking variable. So lurking variable or those variables will have effect on your response variable, but you forgot to mention them or you didn't consider them in the study. Okay? So now if you have a lurking variable in the study, and then the effect of lurking variable and another explanatory variable get mixed up and you don't know which one had effect on your response variable. Either the study time had effect on your response variable or noise from other class had effect on your response variable, your test score. If you cannot distinguish between the effect, that situation is confounding. So confounding happens whenever the effect of lurking variable and the other explanatory variable mixed up and you cannot distinguish which effect was, on your, which one had effect on your response variable. Do you have any questions so far? Okay. So, now in experimental study, we have different kind of term definition that you should know. Some of them are easy to understand because we already have them. We are just changing the name. So what was the individuals in a study? Like in a study of exam score and a study time, individuals were students, correct? Is that correct? So individuals were subject, object, animal, people, whoever that we are collecting the information from, and we are interested to do some, kind of study on them. In experimental study, so now we know what is experimental study, correct? In experimental study, instead of calling them individual, we say these are the subject of a study. So subjects of a study are those individuals in the study. And then in an experimental study, so what was explanatory variable? Explanatory variable was the variable that caused a change in response variable, correct? Will have effect on response variable. These explanatory variables in experimental study are factor. So you already know all of these terms, just the name changed, correct? So in experimental study, we call them factors. So if I ask you what is the factors in experimental study, you should look for explanatory variables. And then the last one is treatment. Treatment is any condition or any, you can say at some point, different level of explanatory variables considered as treatment. So any conditions that we are imposing on individual will be treatment in the study. For example, if I have some patient and I'm giving them some pills, these pills will have different dosage, right? The high dosage, lower dosage. So the high dose will be a treatment. The lower dose will be a treatment. So these are different conditions, correct? So some specific condition in experimental study. So we say any specific condition. Experimental condition. Okay, so if we have just one factor in our study, let's say I have some patient and I'm giving them some pill to see how these pills will have effect on their pain, and these pills will have just two levels, higher level, lower level. Okay, so if I have just one factor, so pills will be a factor in the study because pill will be explanatory variable which will have effect on patient's pain, right? So if each pill is explanatory variable in parentheses a factor because we are dealing with experimental study, this pill has two different levels, so we have two different conditions, just two different conditions. That would be treatment. So higher dose of pill or lower dose of pill. But let's say in different situation, we have two different pills. And each of these pills have different levels. In that situation, when we have more than one factor, means two pills, treatment is not just level of each factor. Treatment will be combination of different levels. So if this pill has two different levels, other pill has three different levels, combination will be 3 multiplied 2, 6 combinations. So how I can write it down? So let's say the easiest example, let's pill will be the easiest example. Let's consider that as example. First pill, and then I have the second pill. And then here I have low dosage and the higher dose. But here, let's say I have 2 milligrams, 3 milligrams. Let's just keep it, each of them has two different levels, okay? So 2 different levels here, 2 different levels here, combination should be 4. So I am talking about treatments, okay? So if I want to write down the treatments, I should write down the combination of different levels. So combination of different levels. We know multiplying these two different levels gives us 4. So 4 is this one. One of them is the low dosage of the first pill with the 2 milligram the second pill. So this is one treatment. The second treatment will be low dosage of the first pill with 3 milligrams, right? Of the second pill. Correct? So now we are done with the low dosage of this one, this pill. So we should consider this one now. High pill 1, the high dose of pill 1, one time with 2 milligram pill to 3 milligram pill 2. So these are different combinations. So we have 1, 2, 3, 4 combination, and these are the treatments for us. Do you have any question? So if we have some experimental study, we should be able to find the subjects of a study in that experimental study, because we already know subjects are individuals of the study, right? So that wouldn't be a kind of difficult thing. It will not be difficult. Then we should be able to find the factors. Factors are explanatory variables, right? And then we should be able to find treatments, which if we have just one factor, that's it. Just whatever level that factor has. But if we have more than one factor, we should find a combination of different factors, and that those combinations are treatments. Okay? So please write this down. This one. You don't have to write this down because we just read it and we will find which one is explanatory, which one is observational, which one. Yeah, just write down the first question. you are done, try to find the response variable, factors.
So we can just list them using the letters.
Yes. Kind of, yeah, write down briefly, like letters, exactly. Factors are the explanatory variables in this study. What are the explanatory variables? Explanatory variables are those variables which have effect on the response variable. And then each of these explanatory variables will have different levels, right? Like pill was one explanatory variable and it had different levels. So let me write this here. X cause change in Y. X has effect on Y. And as if you remember, we said X predicts Y. Y is predicted by X. Okay, so what it says scientists conducts an experiment to determine the best combination of indoor and outdoor exercises in women over 50. Their study has 3 different types of indoor exercises: jump rope, stair stepping, the plank, and 2 different types of outdoor exercises: hill sprint, and what is that? Directions. And then it says the experiment compares all combination of indoor and outdoor exercises. 90 randomly assigned women over 50 years old are the subjected to each treatment. Heart beating is compared before and after treatment. What is the response variable here? Heart beating, right? They are recording heart beating after and before exercise. Is that correct? So the response variable is the heartbeat. So what has effect on heart beating? Exercises, correct? So what exercise? Indoor exercise? Outdoor exercises, right? So what are these indoor exercise, outdoor exercise? We call them factors because they are explanatory variable, right? Because indoor exercise, outdoor exercise will have effect on heart beating, right? So response variable, we said and then factors. 1 is indoor exercise, and then we have outdoor exercises, right? So these two have effect on heart beating, right? So now, each of these will have different levels, right? So the indoor exercise has 3 different levels, J, S, P, right? Correct? Outdoor exercises will have 2 different levels, HS, D. Correct? So 3 levels here, 2 levels here. Combination will be 6. 3 multiply 2. 3 multiply 2. We have 6 combinations. And the combinations are the treatments. Correct? We already have the factors here. This is factor, this is factor, correct? So now to write the treatments, to write down the treatments, we say one of the treatment is the first level of this one with first level of this one, right? I'm not subtracting. You can use anything like dot or anything. Just I'm saying these two together, right? So the first level of this one with the first level of this one, but we have the first level of this one with this one too, right? Correct?
Yes.
So 2 treatments so far. And now, second treatment with both of this. One time with this, one time with this one, okay? And then now, the last level of the first factor with both of the levels from the second factor. And these are 6 treatments we have. Yes?
So it doesn't matter if we change the order for example, H as in J, H as in S, H as in P?
No, it doesn't. So she's saying, okay, let's say we consider this first, say HS, then J, HS, S, HS, P. Doesn't matter. So let me write down. So maybe you write down like this. And then D with each of them. Correct? So it doesn't matter. Okay, so who are the subject of this study?
The 50-year-old.
Women over 50 years old, right? So, do you remember the definition of population?
Yes.
Entire group of individuals, right? So now, do you know who are the individuals in this study?
Yes.
Subjects or women over 50 years old, right? So if I ask you, what is the population in this study? You will say, entire group of women over 50 years old. Or you can just say all women over 50 years old. Correct? So you can say all the women over 50 years old or entire group of women over 50 years old. Yes.
You don't say 90?
No. No. So, because she says they chose 90 women. Where's that actually? Oh, okay. I saw that. So if I ask you, did you say something? What is that? Sample. If I ask you what is the sample, you can use that. But there is more detail here. what they said. They said 90 randomly assigned women over 50 years old are subjected to each treatment. So we should be careful here. Either they are choosing just 90 women overall for all these treatments, or they have 90 different women for each of treatment, because we have 6 treatments, right? 90 women for one treatment, 90 women for other treatment. For 6 different treatments, they have 90 women probably. So we should be careful here to what exactly they mean. Either 90 women randomly assigned to each treatment, or 90 women separately for each of the treatments, because we have 6 different treatments, right? So it should be more detailed. In that case, I would ask you what is the sample. If I explain it more, you know, what exactly I mean. For each of treatment, or 90 overall is my, you know, the women that are in my sample. Do you have any question? No? Okay, so the next one says, an exercise psychologist think carb loading, eating large amount of carbohydrates. Still, I don't know how to pronounce that. Hydrates.
Oh, carbohydrates.
Tomorrow again, I will forget. Carbohydrates. Before intense exercise benefits marathon runners, and it says the psychologist asked several participants in a local marathon for the number of calories from carbohydrates they consumed before the race. Finishing time were then compared in 15 low carb eating participants and 50 high carb eating participants. Is this observational study or experimental study?
Observational.
Observational?
Yeah.
How many of you saying observational? How many experimental?
I mean, he didn't change the amount of carbs, he just passed.
Okay, so you think observational, correct? So it's correct. Why? Because they are just asking them what they ate, how much calorie they consumed, right? They didn't give us different portion of food and this is this much calorie, that is, you know, another calorie, and compare them, correct? So no treatment, they didn't impose any change, correct? So yes, it's observational. Okay, now I should tell you, and I'm recording this for other students if I forgot to. I'm asking some of my students in past, is this observational study or an experiment? They will answer yes, no. So what that means exactly, yes or no? I'm asking, is this observational study or experimental? Either you should say observational or experimental, right? Yes or no is not the answer for this question, correct? You should say either observational study Y, either experimental study Y. So please be careful. In this kind of question, answer is not yes or no. Okay? Answer is either observational or experimental. Why you chose observational? Why? Because exactly. We didn't impose any treatment. There is not any treatment here. They didn't impose any change, any treatment. That's it. Okay, if you choose experimental, you should say what is the treatment and what, you know, if they imposed any treatment. Okay? So now, let's go back to the notes. And I have a question here. It says, a well-known relationship exists between shark attacks and ice cream sales. Means if you eat more ice cream, that shark will bite you.
What?
Because you're so sweet.
Shark will bite you if you eat more ice.
You understand the relation? So it's obvious, right? More ice cream, don't eat ice cream, very good. Okay, so relationship exists between shark attacks and ice cream sales. Both of them increase at the same time. So the relationship is often used to demonstrate how two seemingly unrelated events can often vary together, which requires those who notice the correlation to consider what lurking variables might be in effect. How might you explain the correlation? Either more people buying ice cream causes shark to attack, or shark attacks cause people to buy ice cream. So they have an attack and they go buy ice cream because they feel bad. So do you see the relation? So there's a high correlation here, but it doesn't make sense. There isn't a relation between ice cream and those sharks, correct? So what's wrong here? What you will see, and don't read the rest. So obvious. It's summer and it's hot outside, and they need to eat ice cream, and it's something always in summer happens, and then they are swimming also, and then shark attack, correct? In winter you don't have any ice cream, stand there, so obviously you don't get bite, with shark in winter. So in summer, because the weather is hot, so they need more ice cream, they will swim, and all of this happens. So the lurking variable here caused this kind of high correlation, correct? So the lurking variable is the weather, the temperature. And there is a relation between temperature and, ice cream sales. There is a relation between temperature and swimming, and that's why, the shark attack happens, correct? So here, this example explains the relation of, the lurking variables. Okay, do you have any question? So, there are more definitions in this chapter that we should go through. So, first of all, I will go through principles of experimental design. So like previous chapter when I said the best kind of sampling design is simple random sample. Why? Because they are choosing individuals randomly, correct? So this randomness is very important either in observational study or experimental study. And it will kind of control some errors, control some like lurking variables, some other variables. So there are some principles of experimental design. And one of them is obviously randomness. We should choose our individual subjects randomly to assign them to different treatments, for example. So these are the explanation of what is randomness in experimental study. It means choosing subject randomly and assign them randomly to different treatments, okay? So now there are more of them. It says control. These are the principles of experimental design. They control the effect of lurking variable. As we saw now with previous example, lurking variable can have a really huge impact on the response variable, right? So we should always be careful and control the effect of lurking variable if we have any, or if we, suspect there is any lurking variable. So in experimental study, we always try our best to control the effect of lurking variable on response variable. And then it says randomize, use chance to assign subject to treatment. So as I said, you will choose subjects randomly and assign them to different treatments. And this is the definition of, randomly assigned. And then replication, it says you should have enough subject to assign to different treatments. With less amount of subject, maybe you cannot get a good result, and maybe there were some errors happening, and we should always have enough number of subjects, and we call that replication. So it means repeating this kind of experiment over and over with different subjects, assigning different subjects to different treatments. So this is the principle of experimental design. Okay, so now there are different experimental studies. It says randomized comparative experiment. In randomized comparative experiment, we should have more than two treatments. So we should have enough treatments to assign different subjects randomly to these different treatments. And this is kind of comparing the effect of different treatments on different individuals in different subjects. So this is kind of one type of experimental study. And the next one, it says completely randomized design. So here they didn't mention either we have one treatment or two treatment or more than that. But they are saying you should completely randomize and assign all the subjects randomly to different treatments. So the difference here mostly is the number of treatments and how you randomly assign them, assign the subject to these treatments, more than two or more than two. Okay, so it says, let's see. The other one is, the other experimental design is double-blind experiment. We're going to talk about and match pair design. But before explaining those, let's define this term, statistical significance. Statistical significance. Do you remember bias? Last class I was talking about bias.
Yes.
Bias had a definition. If the result of experimental study systematically favors a certain outcome, we say the result is bias. Correct? So now statistical significance also important here. It's important here. It says an observed effect is so large that it would rarely occur by chance. What that means the result you get, if you repeat this experiment over and over and over, you will get the same result. And for sure it was not luck or it was not accident that you got this result. Like effect of pills on patient, if you repeat that experiment over and over, definitely you should see these pills have a high impact on people's pain. And it's like the result is that big and that effective, you will say, yeah, definitely there is some evidence that these pills have effect on this subject's pain. Otherwise, if effect was so small, you would say maybe these are not effective. Maybe we should consider some other way, other treatments to see if the result is statistically significant. So statistically significant overall says the result you are seeing didn't happen by chance. There was some reason behind that because the result is so obvious and the effect is so big. Okay, so that is a statistical significance. And then the other type of design is double-blind experiment. In double-blind experiment, which mostly happens in labs or hospitals, patient and people who are interacting with those patients, they don't know exactly what is going on. Means they don't know what pills or what treatments these patients are receiving. And patients also, they don't know. So everything is like kind of hidden from them because there are something that we should know. Do you know placebo effect?
Yes.
How you pronounce that?
Placebo.
Placebo?
C-A-B-O.
P-B-O, placebo. Yeah, placebo effect. Because of this, they have to hide the treatment and what these patients are receiving. So I have a real life example for this kind of patient. So some people think a certain pill really have effect on their pain. So like my dad, all these years, whenever, I mean, how many men we have here? So good amount. Yeah. So I'm talking about my dad, so I'm not disrespecting him. So men are so, when they get sick, it's like, you know, it's end of the world, correct? So my dad is that type of person, and he's really, I'm sorry, exaggerating. Hi, Dad. So he always tells my mom, I'm dying, give me something. For example, if he had a headache or something, you know. And then sometimes my mom is such a doctor. I mean, in traditional country, they have all the medicine possible. You don't need doctor, okay? They have everything possible, and it's not illegal to, you know, prescribe medicine to your own child or your own family. That's totally illegal, okay? So no worries. It's totally different from America. So my mom is here, doctor, and she has to have something to give my dad to, you know, cure his kind of pain. So sometimes my mom doesn't have something, and there is some vitamins, some, you know, kind of random pills like antihistamine for neutroning, yeah, for allergies, something like that. And she brings it out and says, luckily I found something here. And then my dad takes the pill, and then after 20 minutes, 30 minutes, my dad comes back so happy. Thank you so much. That was so effective. Thank you. And this is the scenario always happens. So even that pill is not effective at all. Just the thought of, you know, giving the pill, and this pill is definitely, you know, effective, makes my dad feel good, and pain is gone. So this is a placebo effect. And it always, even my brother and I always try to tell my dad, but he trusts my mom, and he never wants to accept that. I swear, we tried our best, but always the same thing happens. That sometimes my mom even tried to do this to prove to us it's still, you know, happening, and give him a kind of wrong pill, and it's still the same thing. Oh no. Yeah. So this is the placebo effect. That's why they hide the treatment from their patient, because they don't want patient to think because they receive something, so now they feel better. So that's the reason they do kind of double-blind experiment. Okay. So match pair design. It says the idea of experimental design is to create matching pairs of similar experimental units for comparing two treatments. Okay. So maybe this is more difficult to understand, just definition, but this example will explain everything and compare other design with match pair design, and explain it way better. So it says, thus talking on a hands-free cell phone with truck drivers, undergraduate students drove in a high-fidelity driving simulator equipped with a hands-free cell phone. The car ahead brakes. How quickly does the individual or subject react? Let's compare two designs for this experiment. There are 40 student subjects available. In first design, which is completely randomized design, all 40 subjects are assigned at random 20 simply to drive, and the other 20 to talk on the cell phone. So they separated these 40 individuals to two groups. 20, just one treatment, 20 others, another treatment, correct? And this design is completely randomized design. And then in the other design, which is match pair design, that was actually used, all subjects drove, both with hands-free and without, with cell phone and without cell phone. Means all these 40 subjects are receiving both treatment, correct? So this is the difference between match pair design and the other design, which is completely randomized design. The first one, which is completely, they separate them to two groups, and each of them will receive treatment. But match pair design, all the individuals or subject will receive each of these treatments. Okay, once one treatment, the other time another treatment. So this is a difference between match pair design, and I think this example explains the match pair design better, much better than just definition. Do you have any questions so far? Any question? Okay, so the last page of this PDF has all the definition we have today. And let me see if I remove the block design. Yes, I removed the block design. So this is a kind of good reference for you to go through all the definition. We are done with chapter 9. And so for the second exam, we have 4 chapters, correct? Chapter 8, 9, 4, 5, right? So we are done already with all these chapters, and we have 2 more sections before your exam that we are going to just practice different examples, and you should bring your questions to the class so we can review everything, okay? And I think, do you have any questions? 28 March, end of March.